Hey kids, welcome to section 1.3, rate of change and slope. Today we're going to learn how to find rate of change and how to determine the slope of a line. So some definitions in case you've forgotten. Rate of change is a ratio that compares how much one quantity changes on average relative to the quantity change in another. That means, for instance, the more you eat, the more you weigh. The more you exercise, the less you weigh. Different things like that, where you're talking about two different quantities and looking at how the second one changes based on how the first one changes. You guys probably know this as slope, something that you learned in Algebra 1, talked about in geometry. So we're going to introduce the words as rate of change today, and they're all interchangeable. Rate of change can also mean slope. You probably learned that slope is also rise over run. You probably also learned something called slope-intercept form, where the m is your slope. You might have also learned the formula for slope, y2 minus y1 over x2 minus x1. The only one you might not know is the one with the triangles here. And so in math, the triangle means change. And so if you put triangle y over triangle x, that's change in y over change in x. So they're all interchangeable. We're talking about rate of change today. I also gave you a picture over here just of some visuals of what slope can be. Slope can be a rising line where it's positive. Slope can be a falling line where it's negative. Slope can be 0 if you have a horizontal line. And slope is undefined if you have a vertical line. I always think of the V in vertical and the U in undefined kind of go together. So we're going to talk about how to calculate rate of change when it's attached to some word problems. So table A, or part A here, the table shows the temperature of a solution after it has been removed from a heat source. Find the rate of change in temperature for the solution. So let's say you're heating water up to make ramen and you take that water off the stove, the water is going to cool down. So what this table is saying is at time 0, the temperature of the solution is 143.6 Celsius. By the time you get to 5 minutes, it's down to 133.1. By the time you get to 12 minutes, it's down to 118.4. When you want to find the rate of change, I want to know how fast is the temperature going down. So what you're going to do is you're going to choose two sets of numbers in the table. I'm going to choose the easiest ones. I'm going to choose the top one because one of the numbers is 0, and I'm going to choose the bottom one. But it really doesn't matter which two you choose. Whichever ones you choose, we're going to write order pairs for them. So the first order pair is 0, 143.6. The second one is 12, 118.4. Whenever you have a table that looks like this, the x is always on the left, the y is always on the right. Order pairs go x, y. So if I want to find the rate of change, I'm going to do the change in y's over the change in x's. So I'm going to subtract the y's, and it doesn't matter which one I do first. I'll do the 143.6 first, minus the 118.4. And if I do the 143.6 first, I got to do the 0 first. So on the bottom is 0 minus 12. If I had gone the other way and did the 118.4 first in the numerator, I would have had to have done the 12 first in the denominator. So it doesn't matter which way you subtract. Either way, you get 25.2 on top and a negative 12 on the bottom. If I divide those, round if necessary, negative 2.1. Now, rate of change is usually associated with word problems, so I need words here. And the way that you do the words is you put the y word on top and you put the x word on the bottom. So this is negative 2.1 degrees Celsius per minute. Negative 2.1 degrees Celsius per minute. Adding the words makes it a true rate of change. Otherwise, you just have a random number and you don't know what it's telling you. Is it telling you it goes down 2.1 minutes every degree, or is it goes down negative 2.1 degrees for every minute? So you got to label. Okay, part B, the graph at the right shows the number of gallons of water in a swimming pool as it's being filled. At what rate is the pool being filled? Well, notice that the pool is being filled, which means my slope is positive, which means my rate of change is positive. So hopefully I get a positive answer. Well, notice they've already got the ordered pairs for us. I'm just going to rewrite them over here. 3 and 108. So at 3 minutes, there's 108 gallons in the pool. At 7 minutes, there are 252 gallons of water in the pool. So to calculate the rate of change, we're going to do the change in y's over the change in x's. So subtract the y's on top, 108 minus 252, over 3 minus 7. So this gives me a negative 144 on top and a negative 4 on the bottom. Divide those, you get 36. Remember, I wanted a positive number. And do the y word over the x word. So gallons per minute. Doesn't make any sense to say minutes per gallon. We're not loading minutes into the pool, we're loading gallons into the pool. Okay, well, what if it's not a constant getting cold or a constant getting bigger? Up until this point, you've used rates of change that are constant. But many real-world situations involve rates of change that are not constant. The world is not perfect. Stuff doesn't go in beautiful straight lines. These situations are often described using an average rate of change over a specified interval. So because it's not a constant rate of change, I have to look at a certain interval before I can say what the rate of change is. So refer to the graph. Find the average rate of change for the sales for both digital music and ebooks from 2004 to 2009. Compare the rates. So I'm looking at digital music and ebooks from 2004 to 2009. So we need to do separate ones. Let's do music first. So notice that there are lots of different dots along the graph, and I could have chosen any one, but they specifically tell us which ones to look at. So 2004, I'm looking at this red one, I have 200, and since that was at the beginning, the order pair would be 2004, comma, 200. 2004, comma, 200. My second order pair is 2009, comma, 3100. 2009, comma, 3100. All right, so let's find the rate of change. We're going to subtract the y's. 40, or no, that's a comma. Nope. Okay, so we're going to subtract the y's. Let's do the bigger one. 3100 minus 200 over 2009 minus 2004. So if I subtract, I get 2900 over 5, and that gives us 580. Notice it's in millions of dollars, $1 million, and it's per year. So between 2004 and 2009, digital music increased by a rate of $580 million per year. It wasn't exactly every year 580, but it was on average 580 because some of them increased more and some increased less. All right, let's look at ebooks. Again, we're using the order pair 2004, 9.6. And our second order pair is 2009, 165.8. All right, so let's find the rate of change. So you're going to subtract the y's, 165.8 minus 9.6 over 2009 minus 2004. On top, it gives us 156.2. On the bottom, gives us 5. Divide gives us 31.2 million per year. So that means on average, the sales for ebooks went up about $31.2 million every year. It does say to compare the rates. So we can say music has a significantly greater rate. Greater growth rate, we'll say. Significantly greater growth rate. All right, so let's do some more calculating. Let's talk a little bit more about slope. So the slope of a line is the ratio in the change of y coordinates to the corresponding change in x coordinates. The slope of the line is the same as its rate of change. So we've been talking about this. So basically we're taking rate of change from the previous slides and slapping the word slope on it. Basically what we're doing, same idea. We've got the formula for slope, change in the y coordinates over change in x coordinates. We have the formula here, y2 minus y1 over x2 minus x1. Here's a picture. The formula for slope is often remembered as rise over run. It's how much you go up and how much you go over in professional terms, where rise is the difference in y coordinates and run is the difference in x coordinates. So I'm giving you lots of different ways to think about slope. Let's look at just calculating slope flat out. Find the slope of the line that passes through each pair of points. So if you were just to do a quick sketch, 1, -3 is down here, 3, 5 is somewhere up here. I would expect my answer to be positive because the slope is going up. Now it doesn't matter which ones you call x1 or y1, x2 and y2, as long as you're consistent. Slope is the letter m, so we can say m equals. I'm going to do 5 minus a -3 over 3 minus 1. So taking y2 minus y1 and taking x2 minus x1. That gives you 8 in the numerator, 2 in the denominator, gives you a slope of 4. That's a positive number, we're good. But just for funsies, what if I go backwards? What if I do -3 minus 5 in the numerator, and if I do 1 minus 3 in the denominator? Well, that gives us -8 over -2. Guess what, kids? That's still 4. So either way you subtract, as long as you're consistent, you'll get the right answer. Letter B, -8, 11, and 24, -9. If I do a quick sketch, -8, 11 is up here, 24, -9 is down here. I'm guessing it's going to be a negative number. So let's do 11 minus a -9 over -8 minus 24. That gives me 20 in the numerator and -32 in the denominator. Simplify your fraction, -5/8. It's a negative number, so we probably did it right. Also, whenever you're working with a fraction, no matter what math class you're ever in, always reduce it. Letter C, 1, 2, and 3, 2. So if I look, 1, 2 is kind of like right here. 3, 2 is kind of right here. Oh, this looks like a horizontal line. And a horizontal line is going to have a slope of 0. So I'm thinking it's horizontal. All right, let's see what happens when we calculate. So let's do y2 minus y1, so 2 minus 2. And then we have 3 minus 1 in the numerator, or in the denominator. So that gives us 0 divided by 2. Well, if I do 0 divided by 2, that in fact gives us 0. If you can't remember if it gives you 0 or not, use your calculator, divide it, you get 0. And guess what? Horizontal lines have a slope of 0. The second letter is an O. O looks like a 0. Horizontal lines have slopes of 0. Letter D, -6, 7, and -6, -9. So -6, 7's up here, -6, -9 is down here. That's a vertical line. Vertical lines don't have a slope, so let's see what happens. If I do 7 minus a -9, and in the denominator, -6 minus a -6, that gives me 16 over 0. If you try to divide that on your calculator, you're going to get an error. That's because this is undefined. Vertical lines do not have slopes. They are undefined. All right, let's take a look at some pictures. Find the slope using a graph. So now instead of having the order pairs, we now have a picture. So if you look at letter A, you first thing you should do is try to find some order pairs. So places where the graph is going to cross the grid at nice spots. So I'm thinking there's one right here and one right here. Also notice that this graph is counting by 2's because the second mark is a 4. So this first spot is not 1, 1, but is actually 2, 2. And this second dot is 8, 4. Now you have two choices. You can either use the formula to calculate, or you can physically count. So if you use the formula to calculate, you'd have 4 minus 2 on top, 8 minus 2 on the bottom. That gives you 2 over 6. That gives you 1/3. Positive number, positive slope, we're good. The other thing you could do is you could say, ooh, I go up 1 box, and I go over 1, 2, 3 boxes. Oh, the slope is 1/3. Either way is acceptable. Letter B, if you find some nice spots, let's see, this is now counting by 1s, so we got 0, -2 down at the bottom. And let's see, another nice one, -1, +2. There are lots of other dots you could have chosen, kids. If we do the formula, we will have 2 minus a -2 on top, -1 minus 0 on the bottom, 4 over -1, that gives me a -4. It's a negative number, my line is going down, so that's good. I could have also said go down 1, go down 2, go down 3, go down 4, that's -4. Go over 1, that's -4 over 1, that's the same as -4. All right, letter C, if I pick some points, let's see, -2, 0 looks like a good dot, and 0, -3 looks like a good dot. So if I do my formula, 0 minus a -3 in the numerator, -2 minus 0 in the denominator, that gives me 3 over -2. Negative number, my line goes down, I'm good. You could have also said down 1, down 2, down 3, that's -3, right 1, right 2, that's 2. Kids, when you're counting, you always go from the left dot to the right dot. Never count right dot to left dot. Count like you read, left to right. All right, last one, letter D. Notice that the x-axis is counting by 1s, but the y-axis is counting by 5s. So be aware of that when you're finding your order pairs. So for instance, 0, 10 looks like a really nice point. And maybe 1, 15. You could have also done 2 and 20, 3 and 25. There's so many points. So I'm going to do 15 minus 10 in the numerator, 1 minus 0 in the denominator. That gives me 5 over 1. That gives me 5. Now, when you try to count that in this axis, since they're counting by different numbers on the x and y axis, you have to remember that if you go up 5 on the x-axis, and you're only going over 1 when you go on the x-axis. So 5s are on the y's, and the x's are counted by 1, so you have to remember that. The other ones, we didn't really have to worry about that because they were counted singly, or at least the same on each. Okay, example number 5, find the rate of change using an equation. So we did find the rate of change using ordered pairs. We did it using a graph. Now let's do it using an equation. Remember, in an equation, we're looking to get it into y equals mx plus b. This is where you can then find your rate of change is the number in front of the x. You can't just start by saying, oh, it's 16. That's the number in front of the x. Notice the left side is not y equals. So we need to make the left side y equals. And so if we divide the left side by -2, we have to divide the right side by -2. Well, when I do that, notice that I have 2 things on top and only 1 thing on the bottom. Well, what we're going to do is we're going to take each of the things on top and divide it by the bottom. So we're going to take the first thing on top and divide it by the bottom. We're going to take the second thing on top and divide it by the bottom. So 16x divided by -2 minus 41 divided by -2. Now simplify that. 16 divided by -2 is -8x. And negative 41 divided by a negative 2 is a positive 41 over 2. Your rate of change is the number in front of the x, so your rate of change is negative 8. So the goal is to solve for y and then find the number in front of the x. Letter B, 1/6 y plus 3/8 x equals 24. So first thing, you need to get the y alone, so let's minus 3/8 x to both sides. So that gives us 1/6 y equals, and I'm going to put the x part first, negative 3/8 x plus 24. Now I got to get rid of this 1/6, so I can either divide everything by 1/6 or I can multiply everything by 6 over 1. That means everything on the right side. So that means I have to do negative 3/8 times negative 6 over 1. So that gives us 18/8 x. And then I have to do 24 times negative 6. So again, you're distributing this. This is going to give you a negative 144. Sorry. You're not multiplying by negative 6. You're multiplying by a positive 6. I don't know why I said a negative 6 there. That was confusing me. Okay, so yeah, you're only multiplying by 6. So this gives us negative 18/8 x, and this gives us positive 144. All you got to do is simplify. So simplify this fraction down to negative 9/4. And then grab your number in front of the x, so your rate of change is negative 9/4. All right, last one. This is an application problem. An airplane descends along a straight line path with a slope of negative 0.1 to land at an airport. Use the information in the diagram to determine the initial height of the airplane. Well, what they're saying is the slope of this line going down is negative 0.1. Now, slope is equal to rise over run. So let's think about slope is equal to rise over run. In the picture, what's the slope? Well, the slope is negative 0.1. What's the rise in the picture? Well, it's got a question mark, so I'll put a question mark. What's the run in the picture? The run in the picture is 50. Now, the other thing you got to think about is that if you're going, if you're thinking of this as like a coordinate plane, this run is going to be 50. Then think about this negative 0.1 as negative 1/10. The other thing, think about this question mark distance as going down. So this is really kind of like a negative question mark. I'm going to change those to x's because the question marks are looking a little funky. So let's change those to x's. And let's remember that the distance was going down. So it's not that you're like going below the earth or anything. You're just going down. Now, this is a proportion solved by cross multiplying. So take the negative 1 and times it. Well, I don't know. You don't have to think of it like that. You can think of it as just multiply both sides by 50. Multiply both sides by 50. So that gives us negative 50 over 10 equals negative x. So that's negative 5 equals negative x. Divide both sides by negative 1, and you get x is 5 miles. So he is 5 miles up in the air if his rate of change is negative. All right, kids, that is the end of section 1.3. If you have any questions, please let me know. And as always, keep calm and keep trucking.